Hello everyone. We are going to see the phenomena of achromatism. Achromatism is a procedure to remove, minimize aberration in lenses. Since we are knowing that aberration is defect in image in their color and size formed by the lenses. It is of two types: spherical aberration and chromatic aberration. In spherical aberration, only blurred image is obtained. Enlarged image of point object, and in chromatic aberration the both defect is obtained, blurred and colored. So either to remove chromatic aberration or spherical aberration, this procedure is called achromatism. This achromatism is, we are going to see a mathematical term by which we will try to obtain to remove the aberration in the lenses. So to do this, we will take combination of two lenses. See what is a combination of two lenses. So before to see the combination of lenses, let us see the formula for axial chromatic aberration. Axial chromatic aberration is given by formula Fr minus Fb is equal to omega Fy. It is represented by equation number 1. Equation number 1 clearly speaks that aberration, that is Fr minus Fb, depends on two factors. First, omega, that is dispersive power of lens, and second, mean focal length of lens. Since both factor is not zero, neither omega nor Fy is zero, this implies that aberration Fr minus Fb cannot be zero. So see how can it be minimized. So minimized, we are going to select two lenses, L1 and L2. This is lens, two lens, L1 and L2. Their dispersive power is omega 1 and omega 2, and refractive index for their color, mean color ny1, nv1, nr1 for yellow, violet and red color, and for second ny2, nv2, nr2. It means both lenses is made up of different material. It means is one of the flint glass, then second we may take crown glass. So material of lens is a different. Now let us see the mathematical expressions for first lens. For first length, 1 upon fv1 is equal to nv1 minus 1 by r1 minus 1 by r2, and another end color fr1 is equal to nr1 minus 1 upon r1 minus 1 by r2. Right? Now for mean color, 1 by fy1 ny1 minus 1 by r1 minus 1 by r2 take as equation number 2, 3 and 4. From equation 1 and 2, one may obtain 1 by fv1 minus 1 by fr1 is equal to nv1 minus nr1 1 by r1 minus 1 by r2. This is equation, and further we are doing the same process as we have done in the formula for axial chromatic aberration derivation. This derivation can be seen in my YouTube channel. So nv1 minus nr1, this is, we are going to divide by ny1 minus 1 and multiply by ny1 minus 1 in a bracket 1 by r1 minus 1 by r2. This is 1 upon fv1 minus 1 upon fr1. This is omega, and by equation 4 it is 1 upon fy1. So using both relation, this expression can be written as 1 upon fv1 minus 1 upon fr1 is equal to omega 1 by fy1. This is fy1 and this is omega 1. This expression can be written as equation number 5. Similarly, we can write for lens L2, that is 1 by fv2 minus 1 by fr2 is equal to omega 2 by fy2, equation number 6. See what we are going to do. We are going to add equation 5 and equation 6. Let us see what happened. Left hand side plus left hand side and right hand side plus right hand side. So it can be seen in this way: 1 upon fv1 plus 1 upon fv2 for violet color minus 1 upon fr1 plus 1 upon fr2 is equal to omega 1 upon fy1 plus omega 2 upon fy2. This is equation number 7. See the change which we are going to do. 1 upon fb is equal to 1 upon fb1 plus 1 upon fb2. In place of this, the focal length for violet color, and we may use the similar concept for red. 1 upon fr is equal to 1 upon fr1 plus 1 by fr2. So using these two relation, expression 7 can be written as 1 upon fb minus 1 upon fr is equal to omega 1 upon fy1 plus omega 2 upon fy2. Now this equation 8 has a mean. So how we will do with deal with equation this is for achromatism. Achromatism means to remove the chromatic aberration. Blurred and colored both effect of a white object. FB must be equal FR. So focal length for all color ray must be same. So if it is same, then this implies that 1 upon FB minus 1 upon FR will also be 0. So if this total factor is a 0, then equation 8 can be written as omega 1 by fy1 plus omega 2 by fy2 is equal to 0. This expression can also be written in this form: omega 1 upon fy1 is equal to minus omega 2 by fy2. This both equation, either say 9th or 10th, is called condition of achromatism. If both combination of lengths, see in this derivation, we have taken two lenses and we have made a mathematical expression for this. If both lenses satisfy this formula, then we can obtain. Now see the meaning of this expression. The special case 1. What is this? If omega 1 is equal to omega 2, then what will be? See in equation 9, 1 upon f1 fy1 plus 1 upon fy2 is equal to 0. So this is average focal length, combined focal length, resultant focal length 1 by fy is equal to 0. What this mathematical representation represent? This fy becomes infinite. It means that combination of lengths behave like glass plate. So no lens will be there. So for the lenses, both material must be of different both material must be different. If one is crown glass, second must be flint glass. By this, omega 1 and omega 2, their dispersive power may be different. The condition of achromatism is omega 1 upon Fy1 is equal to minus omega 2 by Fy2. This implies that if Fy1 is positive, then Fy2 must be negative. It means both lenses should be of different nature. If one is convex in nature, so second lens must be concave in nature. So two things is very important in the combination of achromatism. Both lenses must be made up of different material, and out of them, if one is convex lens, second must be concave lens in the nature. And combination of lens. If you want convex lens, real image is formed by the convex lens. So in that focal length, the combination of this is must be keep in such a way that the resultant focal length, so power of convex lens must be greater than power of concave lens, because if you want a convex lens as a resultant. So these are the three conditions applied, then phenomena of achromatism can be obtained. This is for a topic. Thank you and have a nice